Hello and welcome back to this NC4 video series where you'll learn how to set up and use the Renishaw laser tool setter. Today we have something a bit exciting to show you, which is actual tool measurement. So we're going to kick off today with the most common use of the NC4, which is tool length and tool diameter measurement. So I welcome back Ian, who has all the technical know-how on the NC4. So Ian, before we get started on the machine, I know that some users like to pre-measure their tools offline. We, however, are measuring our tools on the machine. Could you describe the advantages of measuring on the machine as opposed to offline?
Yes, well, when you are measuring on the machine, you are measuring the tool in its true cutting environment, and therefore any thermal inaccuracies inside the machine are compensated for. And also, when you're measuring in the machine, we're compensating for any thermal lift or any spindle pull-up.
So what is spindle pull-up?
So spindle pull-up is where, when the tool is rotating, the spindle tends to expand. So when you put your tool holder into the taper, when it's static, what happens is as it expands, the tool holder tends to move up further inside the actual spindle. And therefore, there's some inaccuracy generated from that. And that's why we always like to try and measure at the same speed you are cutting. So if you are cutting at 10,000 RPM, then you would measure at 10,000 RPM. So all those little inaccuracies are taken out of the final measured value.
So to summarize then, it's more accurate to measure on the machine.
Yes.
Okay. So Renishaw provide many tool setting solutions, and they all fall within two categories. We have the contact tool setter, where tools have to move against a physical stylus or a face. Then we have the non-contact tool setter, and this is where tools will break a laser beam, the same as what we have here. So Ian, could you explain the differences between the two, please?
Yes, well, it's probably easier to break it down to three main points. So the first one is with the non-contact system, you're not coming against a stylus. So if you've got fragile tools, small tools, tools with coating, that's obviously a great advantage because we're not going to rub any coating off the tool. The second point is spindle speed. We are trying to match cutting speed and spindle speed to eliminate any growth coming from any spindle lift. And point three, we can do a lot more with the NC4 system. It's much more flexible. We can do things like interrogate individual edges of the tool to make sure there are no chips or any damage. We can drive the laser around the profile of the tool, again to make sure that the tool is intact and there's no swarf or any chips actually on the inserts. So it's a much more flexible system.
So you said small tools. How small a tool can this laser measure?
Well, with our F115 Blue system, we can measure tools down to 30 microns in diameter.
Wow. So to put that into context, a human hair is about 70 microns, so we're looking at about half of that, aren't we?
Yeah, it's very small.
So, before measuring tools, the NC4 needs to be calibrated first. We have covered this in a previous video, so if you need to do so, please check it out. Right, Ian, let's get on with some tool measuring. Could you explain to the viewers about the measurement cycle?
Yes, so we have our main measurement cycle, the cycle number is 9862. And that is broken down into three parts. You can measure tool length only, to measure tool diameter, or you can measure length and diameter in one go.
Okay, Ian, we have two tools here. We want to measure the length of both. We have a drill and we have an end mill. So let's measure the drill first. Could you go through the procedures, please, to measure the length of the drill?
Yeah, sure. So I'm going to use my GoPro app because it just makes life easy when you're typing in the code. So I'm going to measure the drill. So the first question the app is asking me is what spindle speed do you want to measure at? The default is 3000 and I'm quite happy with 3000 on this example. So I can just press next. Then it's asking me, do I want to step over during measurement or keep the tool on the center line of the laser beam? I want to keep it on the center line because we're measuring a drill. And then that finally puts out the input code. So I can just type in G65 P9862. And one other thing to mention really is that with the Renishaw cycles, the tool will come above the laser beam and then search for the laser beam. So it's important because we don't need to put any information into the tool offset page prior to running the cycle. There can be 0 in the tool length, it doesn't matter. The cycle is just going to always make the search. So we're ready to go, so I can reset that. select memory, and cycle start.
Okay, so that was very quick. So has the tool now been updated?
Yeah, so the tool geometry has been updated with the tool length, and we've zeroed the wear value.
Okay, so let's move on to the end mill. Are we looking at the same cycle inputs?
Yeah, the cycle inputs are very similar, apart from one extra input we're going to use on this particular tool. So the app is asking me to enter the spindle speed. I'm happy with 3000, so I can go to next. Now the app is asking me for the step over value. So when we've got a flat bottom tool like an end mill, we always like to try and step away from the center of the tool. So we are going to use an input here called Y. So the tool will come down on the center of the tool, roughly find the measurement, step over, and then take the final measurement towards the edge of the tool. And the way we like to do it is we always look at the diameter of the tool, divide it by 2 to get the radius. So in this case, the diameter is 12. Divided by 2, we get 6 the radius. And then we take 1 millimeter off. So we always like to set 1 millimeter inside the tool radius. So in this case, the input will be 5 millimeters. Enter 5 into my app. Okay, and the line is given for me to type in. So we need to type in G65, P9862, Y5 point. Okay, enter that, press reset, set memory, and we're good to go. So the tool will come down on center first, find the rough beam position, and then move across and get that final measurement just inside the edge, which gives us that little bit more better accuracy.
Okay, so it's still very quick. So what's now been updated?
So now we go to the offset page, similar to the tool before, in fact it's exactly the same. The geometry is being set to the measured length, and we've zeroed the wear.
Okay, so we've now measured the length on both the drill and the end mill. What do we need to do to measure the length and the diameter?
Again, very similar. I would use my phone app. So if I reset that, and now we set the length and diameter situation. First of all, we've got to put in the diameter of the tool, which is 12 millimeters. Then it's asking me for the spindle speed. I'm happy with 3000, so we'll leave it at 3000. The step over, we're going to stick to the same step over, which is 5. And it's also asking me now for a new input, which is the height at which you want the radius measurement to take place. So this comes from the bottom of the tool. So we want to set the radius about 5 millimeters up from the bottom of the tool, because that's a nice area to set on. So we'll enter that in 5, and we have a new line to type in. So we go back to our program. So we have to put in a new input, which is B3, which tells the cycle it's actually length and radius, okay? And we need to put in an input for the diameter, Y5 point, okay? And that's it, ready to go. So press enter there, go into reset the program, go into memory, shut the door, and this time we should get the length and radius measurement.
Right.
So the tool comes down on center again, finds the rough tool length, steps across, finds the accurate tool length just inside the edge. Then we move down 5 millimeters from the bottom of the tool to measure the radius.
So I have just one question. You're talking about radius and you're talking about diameter. Could you clarify?
Well, with our cycles, we always want you to enter the diameter of the tool. So in that example, the diameter of the tool is 12, and I entered 12 into our input line. But it depends on the machine. So when we actually measure the tool, sometimes we'll output the diameter value, or in this case, we want the radius value, because this machine always works with radius. And that's a setting inside the software. That's where it gets a little bit complicated, but that's basically how it works.
Okay, so I can see that the length and the radius geometry have both been updated. Are there any other ways we can use those measured results?
Yeah, so we've done the most basic updating method possible, which is always to update the geometry and zero the wear. But if you manipulate the inputs and maybe use some different ones, and you also pre-populate the tool offset with a nominal value before you run the cycle, what we can actually do is compare the nominal value that you've entered beforehand against the measured value, subtract one from the other, and we'll put the difference into the wear values. And you can even then apply a tolerance to that. So that's another way of using the measure results to update it slightly differently.
Okay, so the drill and the end mill are very basic tools. Can we use the cycle for more complex tools?
Yes, by adding more cycle inputs, you can measure a huge variety of tool shapes. Things like T-slot cutters, single point bar and bars. Pretty much this cycle can measure any tool profile that you would have in your shop.
Thank you, Ian. So today we have covered basic tool length and radius measurement. I hope this has been of some help to you today. Thank you so much for watching. Remember to like and subscribe. See you on the next video. Happy tool setting.